Hello everyone, welcome to Algebra 1, Lesson 83. We're working on operations with scientific notation. So we're going to talk about multiplying and dividing numbers when they are in scientific notation. Let's start with multiplication. So first of all, if I have a number 4 million times 20 million, those are two already fairly big numbers, and then to multiply them together, they're going to get even bigger. So this is where scientific notation really comes in handy. So I'm going to start by writing these numbers in scientific notation. Remember that with scientific notation, you put your decimal point, or you move your decimal point, so that is immediately to the right of the very first non-zero digit. First, as in the first non-zero digit, as you read the number from left to right. So in this case, it would be right here after the 4. Since there are no numbers after it, I don't actually need to write my decimal. I just write 4. Now it is times 10 to the, well, I moved my decimal from here to here. So I moved it 1, 2, 3, 4, 5, 6 places. Now, I have to decide if it's a positive 6 or a negative 6. Well, to do that, I have to think, okay, well, let me just write my 6. Is my true decimal point really to the right, or is it really to the left? If your true decimal point is really to the right, it's towards positive numbers on the number line, so it's a positive exponent. If it's truly to the left, it's towards negative numbers on your number line, so it's a negative exponent. Well, here, the true decimal point is towards the right, so I keep it as a positive exponent. So that's my first number. Now, this would be times my second number. Well, as I read it from left to right, I come to the 2. So my decimal point goes right there. Because there are no other numbers, non-zero numbers behind 2, I don't need to actually write down my decimal point in the problem. It's just 2 times 10 to the, well, I move my decimal point 1, 2, 3, 4, 5, 6, 7 places. My original decimal point is to the right, so it is 10 to the positive 7. And my marker is dying on me rapidly, so I'm going to switch it. All of my markers are slowly dying. I missed the trash can, sorry. Okay. Let's see if this guy works any better. Maybe he'll work for a minute. Okay. So there we go. Now, to multiply, it's super simple. Because with multiplication, see, I already have multiplication. 4 times 10 to the 6th times 2 times 10 to the 7th. In multiplication, I can move my factors around and it doesn't change anything. So I really could say it like this. 4 times 2, so take my two coefficients here that I have, times 10 times 6 times 10 to the 7th. Not 10 times 6, excuse me, 10 to the 6th times 10 to the 7th. Now this one's becoming too light for you to see, so we'll just finish this problem with the blue and then we'll move to a different marker. 4 times 2 I know is 8. Now when I multiply numbers with exponents and they have the same base, keep the base, so that would be times 10. Add the exponents, 6 plus 7 is 13. So my number is 8 times 10 to the 13. Okay, let's try another one. All right, I have 0.003 times 10 to the negative 4 times 2 times 10 to the 20th. This one is already in complete scientific notation, so I don't really need to do anything. But this one is still kind of incomplete. My decimal point to be in scientific notation needs to be there. So this is going to become 3 times, well, I move my decimal point 1, 2, 3 places. Originally, it was to the left. So I moved it a negative 3 places. I moved it backwards 3 places. So I add that negative 3 to the negative 4 that I already have. Negative 3 plus negative 4 is negative 7. So this would be 3 times 10 to the negative 7 times 2 times 10 to the 20th. Now I multiply my exponent, or my bases here. 3 times 2 is 6. times 7, add my negative 7 to my positive 20. That would be what? 13, very good. So I have 6 times 10 to the 13th power. Okay, let's move on to the next one. I have 0.00004 times 10 to the negative 5 times 700,000. Neither one of these are in scientific notation yet, so I need to fix that. So I'm going to move this decimal point over 1, 2, 3, 4, 5 places. So this becomes 4 times 10 to the, well, I moved it backwards 5 places. So I moved it negative 5 places. Negative 5 plus negative 5 is negative 10. Okay, do you guys understand that part? Are you getting that well? All right, if not, please send me a message. Ask me for some extra help with that. Okay, 700,000. This one I move 1, 2, 3, 4, 5 places. So it becomes 7 times 10 to the, well, I moved it forward, so it's positive 5. All right, now I multiply my bases here. 4 times 7 is 28. And now I have 10 to the negative 10 times 10 to the positive 5. Negative 10 plus positive 5 is 10 to the negative 5. All right, that's multiplication. Now let's look at division. If I have 20 million divided by 4 million, I'm going to start by changing this into scientific notation. So I know that my decimal point for right here goes there. So this equals 2 times 10 to the, I move it 1, 2, 3, 4, 5, 6, 7 places forward, 10 to the 7th. This one, I moved it 1, 2, 3, 4, 5, 6 places forward. So it's 4 times 10 to the 6th power. Now I have to look at each part individually. So I have 2 over 4 times 10 to the 7th over 10 to the 6th. So for my fraction, 2 over 4, that's 1/2, and I'm actually going to change it into a decimal. I'm not going to leave it as a fraction. 1/2 I know is 0.5 times. Now when I divide numbers with exponents, remember when your base is the same, you subtract the exponent. So it would be 7 minus 6. So that would be 0.5 times 10 to the 1, which means that it's 0.5 times 10. So I can simplify that even further. What's 0.5 times 10? Well, anything times 10, you move your decimal point. So it becomes 5. Simple, right? Okay. So now, let's try this one. 0.0016 over 400,000. So I'm going to move my decimal point to the first non-zero digit, which would be the 1. So it becomes 1.6 times, I moved it 1, 2, 3 places. Since I moved it backwards, okay, my original decimal point's to the left, it's negative 3 over, this one I move 1, 2, 3, 4, 5 places. Since the original decimal point was to the left, I have a positive 5. So this equals 1.6 divided by 4 times 10 to the negative 3 over 10 to the 5th power. If I divide 1.6 times 4, I get 0.4. Times negative 3 minus 5, excuse me, would be negative 3 minus 5 would be a negative 8. So I have 0.4 times 10 to the negative 8. Now I'm actually not done with this problem even though it looks done. It's not in scientific notation because this decimal point right here is not to the right of my non-zero digit. So I need to move it over 1 place. Since my original decimal point here was to the left, that means I moved it a -1. So I have -8 plus -1 is -9. So it is 4 times 10 to the -9, okay? So don't miss little details like that. All right, now what if I need to combine it? Here I have 0.06 times 10 to the 5th power times 300,000 divided by 1,000 over 0.0009. Well, to do this, I first simplify in my numerator and in my denominator. Then I do my overall division. So it would be like this. I need to first write these numbers in scientific notation. So this I move back here, so I move it 2 places backwards, so it's a -2 places. So it would be 6 times, well, 5 minus 2 would be 3. And this one I move 1, 2, 3, 4, 5 places. Since my original decimal point was to the right towards positive numbers, it would be a +5. Over. This one I move 1, 2, 3 places. So it would be 1 times 10 to the 3rd power. This one I move 1, 2, 3, 4 places. But since I moved it backwards, it's times 10 to the -4. Okay? Now I simplify further. I'm going to write it up here. So I have, let's see, 6 times 3 is 18 times 3 plus 5 is 8. So times 10 to the 8th power over 1 times 9 is 9 times +3 plus a -4, excuse me, would be a, let's see, -1. So I have 9, oops, not times -1, sorry. Forgot a step there. 9 times 10 to the -1. Hold on, I feel like I have missed something here. So let me double check. Oops, this is supposed to have 1 more 0. Sorry about that, guys. So this is actually supposed to be, I move it 5 places over, 10 to the -5th. Okay, +3 plus a -5 is -2. Now we're on the right track. Sorry guys, I wrote the example wrong. Not the first time I've done that. Okay, so now I look at this individually. I have, whoops, 18 divided by 9, and 10 to the 8th power divided by 10 to the -2. 18 divided by 9 is 2 times 8 minus a -2. 8 minus a -2. Be careful about that. It's not 8 minus 2. It's 8 minus a -2. So that would be really 8 plus 2. So this is 10 to the 10th power. Okay, let's look at 2 more examples really quickly. So first I have 0.007 times 10 to the -23 times 4,000 times 10 to the 6th over 0.00004 times 7 million. I'm going to start by changing everything into scientific notation. So I have this one, I'm going to move my decimal point so that it's immediately to the right of my 7. I've moved it 1, 2, 3, 4 places. So that's 7 times. So since I moved it in my original places to the left, it's a -4. -4 plus -23 is -27. So it's 10 to the -27. And over here I have 4,000 times 10 to the 6th. So I move it over. I'm moving it over 3 places. Since my original decimal point is to the right, it's a +3. So 6 plus 3 would be 9. So it's 4 times 10 to the 9th. Divided by, here, it's not already written in any form of scientific notation, so I start from scratch. I move this one over 1, 2, 3, 4, 5 places. So it's 4 times 10 to the, since my original decimal point is to the left and I moved it backwards, it would be a -5. Then here, it's going to be 7 to the 1, 2, 3, 4, 5, 6. I'm moving it over 6 places. My original decimal point was to the right, so it means it's a positive 6. Okay, now I simplify. So I have 28 on top, because 7 times 4 is 28, times 10 to the negative 27, plus 9 is what? That would be 27 minus 9 is 18. Since my large absolute value is negative, it's negative 18. Over, let's see, 4 times 7 is again 28, times 10 to the negative 5, plus a positive 6 would be a positive 1. Now, I just look at these individually. 28 divided by 28 is 1, times 10 to the negative 18 minus 1 would be a negative 18 plus a negative 1. So it would be 10 to the negative 19th power. All right, let's check out the last example. 20 times 10 to the negative 45, 400 times 10 to the positive 20, 100,000, 0.0008 times 10 to the negative 15. Move my decimal point over, so I have 2 times, well, I moved it forward 1, so that's a positive 1. Negative 45 plus 1 would be negative 44. Times, okay, 400 times 10 to the 20th. Move my decimal point over 2 places, so that would be 4. I moved it a positive 2 places, so that would be 20 plus 2 would be 22. Over. Move my decimal point 1, 2, 3, 4, 5 places. So 1 times 10 to the, I moved it forward 5, so it's positive 5, times 1, 2, 3, 4. I moved it backwards 4 places, so that's a negative 4 plus a negative 15, so it's negative 19. Now I simplify what I have. 2 times 4 is 8. Times 10 to the negative 44 plus a positive 22 is a negative 22. Over 1 times 8 is 8. Times positive 5 plus a negative 19 would be a negative 14. Look at these individually. So this equals, I'm going to write it up here so there's a little more space. 8 divided by 8 is 1 times negative 22 minus a negative 14. So that would be 10 to the negative 36. All right. Pretty simple, right? Okay. Oops, I'm sorry, I did that incorrectly. Good thing I looked. Okay, I added these together and that was incorrect. I'm supposed to subtract. Negative 22 minus a negative 14. See, even teachers make mistakes. Minus a negative 14. So negative 22 minus a negative 14 is the same as adding 14. So negative 22 plus 14 is actually a negative 8. So that's what your final answer should be. Okay? If you caught that mistake before I did, good for you. All right, I want you to pause now and do your practice. Okay, you should be back now, done and ready to go. Letter A, you should have gotten 1.4 times 10 to the 9th power. Letter B, you should have gotten 1 times 10 to the 8th power. All right, that's it for today's lesson. I hope you have a great day. Let me know if you have questions. Bye.